Hello everybody, welcome to today's talk, today's lecture about JSON data. So, can you hear me? Is everything fine? Say hello. So, yeah, we are in the chapter about semi-structured data, and we took a look at different formats for semi-structured data. We talked about the classification. Semi-structured means there is no predefined structure like in a relational database where we create columns with their data types and our data has to fit in this columns structure in these tables. Now in semi-structured data, the metadata is part of the data itself. For example, here JSON. We will talk about JSON today. And unstructured data is often full text or other format which does not have a structure. Okay, these are some formats. Last week we took a look on CSV, YAML and XML, and similar to YAML and XML there's the BSON JSON format. JSON stands for JavaScript Object Notation, so it looks like how you define an object in JavaScript. I pressed F12 in my browser and there are different tags, for example, for looking at the elements of the website you are currently at. So you can also press F12 in your browser. I think this is for all popular browsers possible. I'm using Google Chrome here, and there you can talk JavaScript. So you can, for example, say x equals 5, and when you say x, then it prints x. So this is a console, an interactive way. It listens which command you write. For example, the command is x equals x plus 1. That's a command. Then this command is evaluated. Then the output of the command is printed. So without using a print or something, there's no print in JavaScript, it prints the command output, and then again I am asked for an input. So such a console you see in many programming languages. I forgot how the concept behind that is called, something like input, evaluate, print, loop or something. But not input. I didn't remember what it is called. So, but that's the concept of many tools. For example, there's JShell for working in the same way with Java. There you can say int x equals 5 and then just x, and it shows me that it is 5. Or you can use system.out println x, that's the same. Or for other programming languages, Python, there you can say x is 5, and when you say x, it prints the value. So these interactive shells are there for almost all programming languages. I think there's even for PHP. For trying out commands, this is really fine. And here we use JavaScript. So JavaScript is a programming language that you can use directly in your browser. And one data type I used here is integer. So you can say type of x Okay, it is not called integer in JavaScript, it is called number. And JavaScript is not, it uses dynamic typing. It's not strong typing, not a fixed type for a variable like we saw in Java, where I said int x equals something. So I can now say x equals hello, and then x is hello. And when I now ask type of x, then x is a string. So we see two JavaScript types: string, number. What else can we do? X equals true, true, and now type of x is a boolean. So these are now three types: number, string, boolean. X equals 5,555. That's also a number. So numbers are floating point numbers or math.pi. Let's say x is pi, then x is still a number. So the number, boolean, string, and there are objects. That's what the O in JSON stands for. Here JSON stands for JavaScript object notation, and the object is in curly brackets, and within these curly brackets we use a comma separated list of key value pairs. So for example, x has two attributes, first name, your x, it's Xava, and last name Xava x or something. So now x is type of, it shows me objects. Oh, thank you for the live chat. I take a look there. One moment. The live chat for people who are not in the YouTube chat. So, can you repeat your questions, please? Sorry, I forgot to open the live chat in the Crypt system. So, not necessary curly brackets though. An array is also a JSON object. An array is not a JSON object, an array is a JSON array. But that's a question of definition. You are right. It's also possible when we talk about JSON data to not only use objects but also arrays. For example, arrays of objects. So basically JavaScript notation would be a better name. No, in most cases we use objects. So an object is used in curly brackets and we have a list of attributes. This list is comma separated, and an attribute has an attribute name, then a colon, and then an attribute value. The attribute value can again be of one of the JavaScript types. So here we used string, but it's also possible to say last name is X and age is 25 or something. And then X is still an object, and we can now use dot notation of JavaScript. X dot first name, that's now the string. So we can again ask, what's the type of X dot first name? Type of is JavaScript. So this has nothing to do with JSON, just for it's interesting. Yeah, so let me take a look in the other chat. Ah, yeah, very good. The REPL, that was the word I was looking for. So REPL. So here, one person in the other chat said REPL equal means read equal print loop. So the shell here and the J shell that I showed you here, it reads something from the console input, for example 5 plus 3. Then it evaluates this expression, so it is 8. Then it prints the result, it prints 8, and then loop, so begin again from the beginning. And that's the principle of these nice shells here. They are just for an interactive use of a programming language. So an alternative would be developing a Java program in an IDE and then press the play button and then the whole program is developed. So it is not funny to implement classes and subclasses and interfaces here in Java. This is just for very simple things and working in an interactive way. In Python, this is much nicer, or here in JavaScript for simply trying out something. REPL, repeat evil print loop. Yeah, thank you very much. Okay, this is one form of accessing an attribute with a dot notation, but it's also possible to say to work with it as if it would be not an object but an array, an associative array. So let's say X first name. This is an alternative way of accessing the elements of an object. This is nice when you have special characters in the keys. For example, we have here a key which begins with a space or something. Oh yeah, space. This is valid. So then we have a key, the space character, but of course, how can you now say X dot the space? That's not possible. So for these things, you have to use this notation here. But that's also JavaScript. So this is nice for trying out. JSON is not JavaScript. JSON uses the syntax of how you define objects to work with to define objects in the same way as if you would define them in the programming language JavaScript. And here you also see how to define an array with box brackets. So when I say A is an array with some numbers, then I can again ask type of A. Okay, maybe this is the reason why JSON also supports arrays, because the native language JavaScript doesn't make a difference between arrays and objects. It's in both cases for JavaScript an object, because this object has the attributes 0, 1, 2, 3. No, 0, 1, 2. So I can say a.0 in the same way as I did before X of first name. So there my object X had an attribute called first name. The attributes again can be of different types, not necessarily strings. That's at least the case in JavaScript. And for my array, JavaScript automatically generates 0, 1, 2, 3, so the keys in an ascending order. So this would be the first element in the array, this the third one, so it begins counting with 0. Okay, so that's how you do it in JavaScript. JSON is a bit different, but also very similar. That's what the name comes from, JavaScript object notation. We use a notation for defining a complex object like we do it in the language JavaScript. A nice thing is when you have such an object in JavaScript, so you can simply say product equals, and then I copy pasted it here, then it's a JavaScript native object. So I can now say product dot price, and it shows me the price. But often when you load this from a file, you have the whole document as a string. So then you have to first use evaluate to I use a simpler object now. So I evaluate this here into an array. So x equals, now x is an array. So here it was a notation as a string. So when you, for example, import this from a file, then you first have to use in JavaScript evaluate. It means handle the string as if the string content would be part of the code line itself. So you can do evil things with this. When here are commands, these commands are executed. So evil is can be a dangerous command, but it's often used in JavaScript for converting JSON strings into native JavaScript objects. And in other languages, for example Java or Python, you use libraries for working with JSON data. So the same way as you did in the exercise where you work with XML data and YAML data, you have many libraries in each programming language to deserialize a JSON string. So you get a JSON string and it is, for example, converted into a Python dictionary, or the other way around, you have a Python dictionary and generate JSON data. So maybe evil should be called evil. Yes, evil. Exactly. Saying that arrays are also objects, just mistype JSON instead of... Yeah. Exactly. So let's take a look at the 6 data types of JSON. String, number, Boolean. These are exactly the same names for data types as we saw in JavaScript. Then there's object. So this is a number, this is a number, this is a string, this is a Boolean. And an object always begins with a curly bracket and ends with a curly bracket. So the whole thing here is an object. The object has so-called fields. So the attributes are called fields in JSON. And we have 1, 2, 3, 4, 5, 6, 7 fields. And each field has a field name. In JSON, this is a string. In JavaScript, it was possible that the fields are of other types as well. And the field has a value. And the value, again, can be of any of the 6 types. When we work with JSON later, for example, we will do one little chapter about MongoDB as well. MongoDB uses JSON as their data format for storing the data. there they introduced more types than just these 6 types here. So for example, for working with dates and timestamp. Yeah. And you see here's a null data type, because what's in JavaScript when we say x equals null and we say type of x? Okay, JavaScript, everything is an object. In this case, it is not clear what is size. Is it an object? No, it does not have curly brackets and does not have any fields. It's also possible to have an empty object. So this is also a valid object. This is an object without any fields. Why not? Or this here is an empty array. But you can do things on an empty array that you can do on arrays. For example, you can count how many elements are there in this x.length. How many elements are there in the array? That's possible because x is an array. It is empty, but it is an array. Here it is not an array, not an object, not a string, not a number, not a boolean. The data type is called null in JSON. Null is a data type and it has only one valid value, null. Boolean has 2 values, true and false, and string and number, you know. And for the object, here's an example of a product which has a manufacturer, and we use the nesting syntax here. So manufacturer is again an object with the keys company and country. So when this would be a document called P, I think I called it product, then we can say product dot price to get the price, and product dot manufacturer dot country or so to get the nested. So with a dot notation we go into the document structure. Okay, that was JSON, and I think you all saw JSON before. If not, then you know now the most important things. JSON uses the JavaScript notation of how to define objects and arrays. It supports nesting because the value of a field can be again an array or an object. And then with these 6 data types, you can have arbitrary structured data. You can have an array an array, and in this array you have different objects. So here's an array with 2 objects. And this object A is 5. Let's call it different than the name itself. Name is Peter, and in this object name is Paula. So this is now an array. You can access the first element and then say dot name, and then you get the name of the first element, name of the second element, and so on. And instead of using the string Peter here, you can also again use a nested object or again an array. So arbitrary nestings are possible. This here is a query language, and it is not so important for you to learn how to use this query language. I just want to show you that flower expressions, which we had last time from xQuery, are still used in new query languages. And this query language called JSONiq, a query language for JSON data, uses the flower expressions for querying. Flower stands for, let, where, order by, return. Flower expressions, and the semantic is exactly the same as for xQuery. So with a let clause you define a variable because it's convenient to define a variable within your query. That's not possible in SQL, maybe with common table expressions, but no, you simply say, I introduce a new variable products, and this is the content. So in my case, I introduced products because I don't access a database here, or I don't open a file where my data is in. I simply put the data in the query just for testing. So my query begins with let products be the following array with 2 products objects. And then my main query begins here with the for p in products. For is similar to let, but it iterates over the elements of an array. So it also introduces a new variable, in this case p, but p is now in each iteration a different value. So products is an array with 2 objects, and p in the first iteration is this object, and then the second iteration is this object. And then the rest is similar to SQL, so you can use a where predicate. It uses GT for greater than, because it doesn't support the characters for greater than, smaller than. Then an order by clause like in SQL, and the return clause builds the result. So I just want to see the description of all products that cost more than 50 cents. And if there are multiple ones, I want to see them in a sorted form, ordered by the description in an alphabetical order. So let me try this out now. Here's a link. On multiple slides I have this try out at link here for simply trying something out that's in the slides. I found this Solver.io, which supports JSONiq. Is it currently offline? Or am I currently offline? There's a question in the chat. I copy and paste the question so that it looks like as if I would ask the question. It will appear in my chat in 8 seconds. There it is. Why is it for foo in bar with braces like it is in a function call? Yeah, that's a detail of JSONiq. I don't know the reason. So I used an example from their side and adjusted it to my example. I don't know the reason why this is a function call, but let me try it out when it loads. But it looks like as if it is down now. JSONiq. Try out. Oh, the other tool was better. Oh, it looks like we'll try it later. Maybe this comes from XPath, like text. No, there in XPath text was a was a node test. So it tests a type test. So it tests a node whether it has the type text. Oh, this is so hard to pronounce. Okay, I will try it later. I hope that the server will restart very soon. But I just put this on the slide, not because it's very interesting now for you, there will not be an exercise about JSONiq. I just want to show you there are query languages for JSON, and these query languages they are inspired by other query languages. So here you again see the flower expressions from jQuery. A much more important query language is JSONPath. That's basically, no, there is no standard query language, but if there would be a standard query language, it could be JSONPath. Why can I say that? Because in databases, in relational databases, there is a JSON type. And we will talk about this in 2 lectures. So in 2 or 3 weeks. And when you have JSON data in a column of a table, then many relational database management systems support JSONPath expressions. And we will now try this out here. So there's a comment about JSONiq again. Pretty sure for Foo and Bar should also work when looking at their iteration example. So maybe you're right that these brackets are simply too much, that they are not necessary. So in JavaScript it makes no sense to say A is an array and then A, no, I cannot call an array. I will try this out when the website works again. Let us try this out at the end of the lecture. So JSONPath uses path expressions. You know them from XPath. There we used /////. The idea behind XPath was being similar to a path in a file system. So I have my root folder of a Windows hard disk here, or when I use Mac or Linux, then the root starts with /, and that's also a valid XPath expression, the root of the XML document. And then you go into the products, and within the products you go into a product node. So we had this last time, and then in the product you go into this description. And the idea was to be similar to folder structures. My folder var lib something, and we saw more similarities. For example, this dot means the current folder, so it is an abbreviation for the axis self, or dot, that's parent. So then we are again in var, and that's also the same in XPath. Now in JSONPath we don't use the /. So / is also used in URLs. So here localhost / mdc slides / and so on. That's also using the / notation. In JSON we use the dot notation, like here in our examples, product dot price and so on. So we go deeper and deeper with the dot notation. typically a JSON path expression starts with $. $. Is, when we work with JSON documents, the root of that document, the root object. Then we access the sub parts with the dot notation. So for example, $.price gives me the prices of products. So now here's another sandbox for trying out JSON path. I use my example. So this JSON document here, copy paste it here, and I say I want $. $. gives me the whole document. So that's my document. It embeds it in an array because typically you work on such data as if you would work with a database. So a set of data items, and this is just one data item. So it simply puts it in an array. Oh no, sorry. This is the result. The result of a JSON path expression is always an array because it can, when multiple things match to an expression, then the array has each result in this resulting array. So this is our input, and our output looks like the input, but here are the array brackets because the result is always an array. Like in oh, it is gone. Like in XPath, the result of an XPath expression is always a sequence of nodes. And here it is an array of JSON objects, or array of strings, or array of arrays, whatever. So an array of something. And this array can be empty, so if nothing matches, so I go into the key invalid, then the result is an empty array because there is no key that has this name. In JSON, the people distinguish between two query modes. I've never seen this word out of JSON. So do you know that word, Lachs? It is not a fish. Salmon in German means Lachs, but you spell it differently. So what does the dictionary say about Lachs? Lasch, locker. Yeah, so the best explanation for Lachs is the opposite. The opposite is the strict mode. So in JSON there's a Lachs mode and a strict mode. Lachs means what we saw here. If it is not present, what we are looking for, then we simply return nothing. The strict mode would raise an exception here. So we will later, when we work with the database, see that we can configure that we say strict and then an expression so that it must match, otherwise an exception is thrown. So if you would compare this with SQL, so when you have an SQL query, select name from people, SQL is strict because if there is no column name, then an exception is thrown. Then you see the result of your query, no such column name. And many other query languages, they are by default Lachs. So when I say $.name and there is no field name, no problem. Maybe tomorrow there will be this field because the structure is flexible. It can change in the future. Maybe for other documents there will be a name. So, and if you want a strict behavior, then you can configure this in many systems. But here it's Lachs. I don't know if it really is pronounced lux. Maybe it's pronounced lex or something. So, one question in the chat is coming up. Let me talk about this question. How would you query something like this? foo.bar for. Okay, you now have a dot in your field name. That's always the problem. We saw this problem in CSV files as well. So there must be a delimiter or an escape character or something. Let's say it is not called product underscore ID. So if it is product underscore ID, then we can say product underscore ID. It gives me the 17. And if it is called product.id, then in the Lux mode it finds nothing. And this of course makes no sense, because this would be if it is product and then a document with the key ID is 5. So this would now not give me 17 but 5, because it goes into the field product and then in the subfield ID. But let's try it out with double quotes. Does not work. So I simply use my try and error. No. So when you come to these limits, you have to Google. So please Google and write me the solution in the chat. I don't know the reason. The best idea is always to not use dots in field names, because then you have these problems. I think in MongoDB dots are forbidden in field names because of this. So JSONPath dot in key. Syntax when dot is in key. Similar to JavaScript, use the box brackets. So in JavaScript, we also had the alternatives to say product. That is not in this anymore. To say dot product ID. This is the answer. So using not the dot notation, but then the box brackets notation is also possible in JSONPath. Okay. But the best idea is always to not use dots in the key, then you don't face these problems. When you have an array, you access the nth element of an array like we did it in JavaScript. And when you don't know the attribute name, or when you don't know the index, you just want to say, I want all attributes or all elements in the array, then you use the star. So access all attributes in an object or all elements in an array. It's just a wildcard for every field in an object, every element in an array. Let's go to this sandbox here. For example, we can say $.star, and it gives us the 17, the ID 5 document, so it gives us all values. Or $.star.country, it goes into all elements that have a subfield country, so that's only the case for manufacturer, and it should show me USA now. or I go into the field categories. The result of this is the result array of the array, which is found in the field categories. And I can go into the first category, that's food, or in the second one, that's sweets, or in all ones. Then basically this box bracket star operator unnests the array. So we will need unnesting very often because JSON data supports nestings, and when we have nestings we need unnestings. So we unnest the array, and the result of this is now multiple results. So you remember these box brackets here is the result array, and before we had only one element in the result array, and now we have two elements in the result array. So when we have a programming language and we say I want to execute this JSONPath expression, then we can iterate over the result of this expression, and this iteration now has two loops, two iterations. We can iterate over the categories of a product, food and sweets. Food in the first iteration, sweets in the second iteration. Then we have something like the slash in XPath. So you remember in XPath we had / price. It recursively goes from the root node or from the current node up to the child elements and their child elements and their child elements to find a matching element. And the people from JSONPath said, yeah, when we use dot instead of the slash, then we simply use dot instead of // So we go recursively to a descendant to search for an attribute. So what we did before with the star dot country, we can now also do with dot country. We go deeper and deeper until we find an attribute that is called USA country. And if we have here also a size which has a country, then it also finds this one. And even if it would be deeper, so here again the company is a field with monster food and country, so it does not necessarily have to be on the same level of nesting. So it finds all values of the key country independent where they are in the document. So there are some questions in the chat. You can use square brackets or dot in brackets. Okay, yeah, that was the solution of the question before. Thank you. And then in the other chat there was the question from the same Stack Overflow thread. JSONPath.com is based on an outdated version on JSONPath and is not reliable for previewing what current libraries would provide you with. Yeah, it is so fastly changing and there is no real standard. And as I said, many relational databases use JSONPath expressions so that you can query the data that's in a JSON column of PostgreSQL or so, or Oracle or whatever. That's also not 100% true. It is similar. So you learn it now, the basic concepts, and when you use it later, you will see, okay, in this case, it's a bit different and so on. But that's the problem when something is not standardized. But even if things are standardized, SQL is also standardized, but there are so many dialects working with SQL Server is different than working with Oracle and so on. So you learn one form, and then when something works different, then you have to Google or find it out or read how to solve this now in another product. That's always the problem with the fastly changing technologies, query languages, and so on. We had predicates in XPath. There we used box brackets. Here we use a question mark. So instead of a star, you can use a question mark. So everywhere where you can use a star, you can use a question mark and then write in brackets after that question mark. Oh, I think here's a bracket too much. Your predicate that you want to check. So for example, let's go into that's very not a very good document for querying. So let's make a new data set. Let's again take our array with Peter is age 22 and another document name Ute is age 20. So, and I want to now query what's the age of Ute. So first of all, let me check whether this is a well-formed document. Yes, it is. Otherwise, I could not query it. So I go into all elements and give me the age. This would give me all ages. One person is 22 years and one person is 20 years old. But I only want to see the age of Ute. So I don't use star. And now within these predicates, we use an add character for the current node. If we would not write something with an add here, we would again start at the root node for checking a predicate. But often you check the predicate at the context node, the current node, where we are currently. So we are currently in the array. So check if the array has, in the current object where we are in the array has the field name, and name, I can never remember when to use one or when to use two equal signs, whether it is Ute. And then it gives me back 20. So this is now a query. And if JSONPath is new for you, these queries look very strange. So many symbols, dollar, bracket, question marks, other bracket, add, dot. So explain this query to your grandma and you understood JSONPath. So what does this query here do? This is now querying a set of, an array of product documents, and we go into those elements which have the price greater than 1. So give me all products that cost more than €1 or dollar or whatever, and then finding those product elements, we go into the description. So this query is something you should understand. We will make an exercise about JSONPath. It will be uploaded today. So this evening or so, I will upload an exercise. You have 2 weeks for solving this, because next week there is no lecture. On Tuesday there is no lecture, and this Friday there is no exercise. So you have 1.5 weeks time for solving this exercise about JSON. Yeah. So when you understand these expressions, then you are well prepared for the SQL JSON part, which we will do in April. Okay, other things I want to talk about today are, for example, JSON schema. We saw XML schemas and DTD last time, and we talked about well-formedness and we talked about validity. A document is well-formed when it follows the syntax of the language. So an XML document is well-formed when every element closes and so on. And a JSON document is well-formed when you use the closing curly bracket, when you open it and so on. But now we will talk about validity. When is a JSON document valid? And a JSON document is valid when it matches a JSON schema. There are many standards for JSON schema. The most prominent one is called JSON schema. And you see here an example which I created, which the document that I showed to you with the product should match. So let's go over this example. This is just an ID of the schema. Each schema has an individual ID. This references the schema of the schema, so it just says that it is a schema and it is following this standard. Can we look in this schema? Yeah, when we open this in a text editor, we see how the schema files should. What's the schema of the schema? Interesting. So, not so interesting. Okay. Then there are some information about the things that follow this schema. So this is not a rule or something. The rule is, for example, this here. The attribute description is required. A document would not be valid if there is not the field description. These here are metadata like the name of a table in SQL. When you create a table, create table products, you define the columns. So the table has a name and the columns have properties and also names and data types. And the same here. So title defines how the entity type which we describe with this schema is called. So we describe what is a product. A product is an object. So something that should be valid to this schema must start with curly brackets. So it is an object. You can define also a schema which is for an array. Then the root element should be an array. So this query here requires that our root element is an array. Otherwise we cannot go into the elements of the root element, because when the root element is an object, you cannot go into the elements. But here again we have simply one product. So this schema does not define a set of products, but one single product. So it's an object. Then the required fields. Description is required. And then some rules. JSON schema says everything is allowed. So we can add additional attributes. We can add additional fields which are not in the JSON schema. But if we use price, then it has to follow the following restriction. So the schema restricts documents somehow. So we do not allow all price values, but only numeric prices. And it must be a multiple of 0.01. So a price of 0.00005 or 1.12345 is not valid. It must be an integer multiple of 0.01. So this is basically the way how to say that we have two fractional digits. So it's like a decimal with two fractional digits. Then something like minimum or maximum, we can say that the price of a product is never negative. It's always positive or zero. And then we see descriptions. So this is also possible in SQL. I don't know if you ever saw this, but it is possible to make comments for tables and columns, so that when somebody looks at your database schema, they can understand your schema better. For example, here this is very useful that you see the price is in US dollar. So this description here is not so necessary because it's clear that is a description of the product. We are at the description field in a product object, so this is usually not necessary. It is clear, it is self-explaining, but maybe that it should be a short description and not a long description. So maybe this is, can be useful. But here this is very useful because people see the prices in US dollar. The rest is arbitrary. So there can be manufacturer, categories, and so on. So let's take this schema and go to the JSON schema validator. On the left side, you put in your schema, and on the right side, you write your JSON document. So description, dishwater taps, price 512, sold out, true, no errors found. If we say the price has more fractional digits, found one error, float value 5.12235 is not a multiple of this. So it checks whether it matches the schema or not. Or if we delete the description, then 2 errors. Okay, this error we can fix now. One error, the required properties are missing from the object's description. We can say categories is also required. Then it's a description and categories is missing. Then I add the description, dishwasher taps, and then categories are missing. Categories is an empty array. Now it is valid again. As I did not specify something about categories, I only said categories is required. I can make a string here or an array or a nested object. That's okay. I did not restrict what categories is. I just said that categories is required. Or I say there's another manufacturer or something, and this is an empty object or so. So additional fields are always allowed. I'm not sure if you can forbid the use of additional fields, but typically additional fields do not hurt. So a schema is good for application developers. You implement an application that works with JSON data. And when you see a schema, it's better than seeing an example document. So you see this example document and then you say, okay, products have a price and they're sold out, but you don't see, is this a good example. Is this example representative for the whole set of documents and so on? So a schema is always better. You see what you expect in the future. You know there will never be a negative price because it's written in the schema. Here you just see, okay, the price of this product is 512, but is it possible to have a negative price? Yes or no? Here it's clearly defined. So a schema is always good, and a schema comes from structured data, relational databases. There you can also say the price is a decimal with 2 fractional digits, and you restrict that the minimum price is 0 with a check constraint. You say the description is not null, so it is required. So that was the two areas, structured data, relational database systems, and semi-structured data, flexible data, and so on. And the application developers said, it is hard to develop an application when you don't know what the data will look like. So they introduced schemas. Even MongoDB, which said, we are a database where you can put all your JSON documents in, independent of how they look like and which attributes they have. They added in a version 5 years ago or something, a schema validation that you say, in this collection, I can only insert JSON documents that match the following schema. Or in relational databases, when you have here an integer column, here a string column, and here a JSON column, you can say that this JSON column only allows values that match the given schema. It avoids errors. So that's the benefit of a schema. And here for JSON schema with the descriptions, it's also a kind of documentation. So it documents how your documents look like. Do you have questions about querying JSON and JSON schema and JSON in general? This is not my... Do you have any questions? Does schema have only defined attributes and descriptions? You mean... So this description here means a product has a description. This description here is a keyword from JSON schema, which is basically a comment. So it comments the attributes. So you make restrictions. When there is a field description in the document, then it must fulfill the following properties. It must be a string, this must be a number, it must be a value with 2 fractional digits or less, and greater or equal to 0. So you just you mean how can you know which properties are valid here? Yeah, you have to look into the documentation of JSON schema to see the schema of JSON schema. So yes. how to validate validation schemas by schemas. I tried to find this out by looking into the schema of the schema, but this was not very helpful. It had just some references, but yeah, a good idea is always the documentation. So the specification. Yeah, so when you specify a JSON schema, take a look into the specification, what's also possible. So it shows some examples. So what can we look like? Let's say uniqueness. Uniqueness is not possible in JSON schema. So we have here products, and products have a product ID, and I want to say that the product ID is unique. That's not possible because when I check this document for this product, the other products are not known. So this is something that's not possible. But what else can we check? So basically here's everything what we need. Data type, some restrictions of numbers. Yeah, let's say the description must not contain an add character or something. So a regular expression or so. So regular expression, pattern properties. It's good to see examples here, but maybe look at examples and not in the specification. That was the idea of this schema. Yeah, I'm not sure about how to do everything, but you can Google if you need something that's not in this example here. For example, regular expression, JSON schema regex. JSONschema.org is nice. Type string, that was the type definition. Min length, max length, and the string must match this pattern. Okay, yeah. So to restrict that not all strings are accepted for product descriptions or so, but only those that have that match this pattern here. This is the pattern of a phone number. Brackets are okay, numbers are okay, dashes and so on, or a minimum or maximum length. So maybe this is a good documentation. Uniqueness within arrays, that an array must not contain the same elements. So basically it's not a list but a set then. So these are things that you can restrict. So a JSON schema is has multiple functions, multiple meanings. It is a documentation. It describes how the JSON documents look like, so that the application developer knows what the documents will look like. It is a restriction, so that not every JSON document is accepted anymore. It is not as flexible as it could be. It is restricted. So it does not allow all price values. It must be a number, it must be at least $0 and so on. So you restrict the flexibility a bit with the schema. Okay, and then in the end of today, I want to tell you one more data format. It's called BSON. Basically, it's not a data an alternative like CSV, XML, YAML, JSON, BSON. No, BSON is just the binary, not the binary, it's a binary representation for storing JSON. So you typically have two different possibilities how to store JSON. One is store the JSON data as a string into a file. The benefit of this is you can open the file in your text editor of your choice. It is a human readable file with curly brackets, a space, a quote, a colon, and so on. But this is not good for efficient search. So we did the query before, what's the age of Ute? Imagine how this internally works. So it has to look at each and every byte, each and every character of that JSON file here, and parse and check grammar things and use parsers to see, okay, that's now a field name, this is a value, okay, double quote, so this is a string. The whole file has to be inspected, so that's not the whole bunch of bytes is loaded. That's not efficient. And it's more efficient to work on a data format which is optimized for search, for efficient search. And BSON is such a data format. BSON was developed, I think, from MongoDB. So when you store a document in a MongoDB database, do I have a MongoDB database running? I think yes. So db.products.find. Oh, they are products. And db.customers.find. No customers. So I insert a customer. We do this in a few weeks. So I insert a customer and say the customer ID is this and the name is Peter. Then it's inserted, and MongoDB stores this document now in a better way, in a BSON format. So how would this document, which has an ID 17 and a product description chocolate bar, how would this internally look in BSON? In the chat there's a question which I will answer very soon. It's about the size consumption. I will ask you later. So I first give you some details on how the BSON format, what's the idea behind the BSON format. I insert a document and it's not stored like a string, curly bracket, space, double quote, underscore ID, double quote, colon, and so on. No, it's stored like this. The first 4 bytes in a file, which stores many of those documents, say what is the total length of the document. So the length field is always 4 bytes, and then 5, 9, 13, 14, 26, 30, 40, 44, 45. So the whole document is 45 bytes long. The information how long the whole document is very useful. Why is this useful? Why is it useful to know how long the current document is? This is my file. Why is it useful to have the total length of the document? Divide and conquer? No. So this is not the only product I store in the database. So I store 1 million products and so on. And then I will ask what's the description of the product 25 and so on. And here I have the length field 45. Then here's information about that document. Then here's the next document that's a bit longer, 51 bytes long. And then again, and I want to find out how much is the dishwasher tabs. Description equals chocolate bar. That's not interesting for me. I'm interested in dishwasher tabs. So when we are here, we can simply calculate. Yes, there it is. For skipping documents, we can calculate how to skip the rest of the document. And that's a big benefit of BSON. Not looking at each and every byte when we search something. That's something we need to do when we work on strings. Here we have a length field. So we are already at byte 27. So 27 minus 45 is 18. So we can jump 18 bytes in the future, no, to the right. We can skip 18 bytes, and for long documents we can skip the whole rest of the document. And here are all the attributes. And in production environments, JSON documents have tens and dozens and hundreds of attributes, so we can skip a lot. In MongoDB, the document limit is 16 megabyte. So we can, in the best case, skip multiple megabytes of data. And that makes scanning fast. We can simply skip to the next document when we know this document is not what we are looking for. Here is something with chocolate bar, but we are looking for the price of dishwasher tabs, so we skip it. And then again we see here something which does not fulfill our predicate, we skip it, and so on. It's not for memory allocation purposes. Maybe, yeah, it is when we delete data afterwards, then we can reuse the space for a document that is not larger than the old one and so on. Yeah, maybe the length field can be of interest there as well. But the main purpose is for quickly skipping documents. The current part can just be skipped by adding the length to a pointer. So exactly. And then in the other chat again, the good answer to skip the next one without parsing. And there was also a question, why is there a length field if string is 0 terminated? Yeah, let's look further here. So we have 4 bytes. These are always 4 bytes. to indicate the length, which also means that we have a maximum of 2 to the power of 4 times 8. So what's this? 4 gigabytes. So a whole document cannot be larger than 4 gigabytes. Otherwise it would not be possible to fit the length of the document in the 4 byte. Then we have for each field the type, the name of the field, the value of the field. So in our case, our document has 2 fields, ID and description. So we have the type of the ID, the field name of the ID, the value of the ID. And when the type is 16, that's integer. So there's a BSON list. What are the type IDs? 16 is an integer, 2 is a string. So we have an integer here, and this integer always has a value length of 4 for the 4 bytes. So we store the type, then the name of the field, ID, to indicate what's when the field name is finished. We have an \0 character here. So in this case the field is 4 bytes long. In this case the field is 12 bytes long, because that's the name of the field. And let's say we search for the price of chocolate bars and we see, oh, here's an ID. Then we can again skip 4 bytes, because we know that the ID is an integer. Integers are 4 bytes long, so we don't need to read this value 17 here, because that's not something we need. We can skip the next 4 bytes. Okay, 4 bytes is not much, but we can skip them. And here for strings, the same. We have a string field, it's called description, and we store the length again in a 4 byte field. So the string chocolate bar is 14 characters long, because the end of string character is here stored as well. Otherwise it would be only 13 characters long. And I cannot answer this question here. Why is there a length field and the 0 termination? So the length field is very useful to skip 14 bytes when we are not interested in reading this value here, but then this is not necessary. You are absolutely right, but I don't know the reason why MongoDB decided that there's also the indicator of the string termination here. Maybe they want it everywhere. So it always consumes 1 extra byte, you're right. And then here's the end of document for the whole document. So that's always there. And here you can also say, why do we need this end of document flag? We know that the document is finished because we know its total length. I don't know the reason. So we are finished for today. This is now an internal form of storing JSON. There's a question in the chat, how is indexing binary search done? Basically, indexing can be done in the same way as you know it from relational database systems. So we make an index on the ID, then all the ID fields are inserted in a B tree or B plus tree, and in the leaves of the B plus tree we make pointers to the positions in the BSON file. And binary search, why binary search? Binary search only works when there's an sorted order, but there is no sorted order. So, and the other search I explained here, so you simply can quickly jump to the next document. Before we finish, I have a question to you. Please tell me the answer, because there was a question. Are there stats how much bigger compressed JSON is compared to BSON? Okay, compressed JSON is consuming less space, but is even worse in efficient search. So BSON is made for efficient search. Sometimes it can have a less memory footprint, consumes less space, but yeah, please calculate on your own now. Does this BSON representation take 11% more space than this string representation, or is it the same, or does it consume 27% less than this? In the meantime, while you are answering and while other people already answered and calculated, do you have any questions on JSON, BSON, JSON schema, JSONPath, JSON query? Which questions do you have? Can you please provide suggested solution for the exercises? The first exercise was just for you to trying out how to work with JSON. So there is no solution. And for the other exercises, there are also no real solutions. You can ask in your Zoom slots, in your exercise lessons, what's the right solution and so on. You can send me your solution and I give you feedback or something, but I will not upload or provide any sample solutions or so. The solution is not so important for exercises. It is important that you work on these topics. Okay, for this here I give you the solution, and so this BSON document consumes 45 bytes. That's written here. You don't have to sum it up like I did it. But how many bytes does this consume? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. 1, 2, 3, 4, 5. Also 45. So, only a very few number of people answered it correct. I wondered, how can you give an answer so quick? So yeah, because maybe you just thought, oh, binary representation, we don't need to store the colons and the double quote characters and so on. And for big data amounts, it may be true that BSON is a bit more compact than JSON, but in general you cannot tell. It can be that BSON is larger, BSON is smaller than the JSON. In this case, it is randomly the same. So sometimes it's so, sometimes it's so. It's not a compressed format. It's a format for faster search. For the exam, what extent detail do we need to know these various query languages approaches in regards to upcoming exercise and the final exam? This is not so easy to say because we work on many different query languages and concepts, and you don't need to know them in detail. You should know what the ideas behind the languages and concepts are. So when I show you the summary slide here, you should tell me what's the difference, what can you express in an XSD that you cannot express in a DTD, or what's the difference between XQuery and XPath? What's the difference between JSONiq and JSONPath? What's possible here that's not possible there? So it's not necessary that you learn the syntax and I give you so the focus in today is JSONPath. So for this language you should know how to make a query. Then I can ask, can you please write down a query in JSONPath that finds the names of the product that cost more than €5 or something. That's something you should know. In JSONiq I don't expect this, and I don't want that you create a schema for me. You should understand the schema, and when I show you a schema you should say, this is a restriction and this is possible with that. So you should know the concepts. You should not be an expert in using all these things. That's not possible. Okay, then let's finish for today. We see us in 10 days or so. So when there's the next exercise on Friday in a week, and the exercise sheet will be uploaded this evening, and the next lecture will be today in 2 weeks, so the week after Easter, and this will be about XML again, but XML in databases, and then we use JSON in databases. Okay, see you then. Goodbye.